All right, everybody. Welcome. 1.7. This is the last part of 1.7. This is rational inequalities. Remember, a rational function is a function with a polynomial in the numerator and the denominator, okay? So, first thing you're going to do when solving these is some similarities to the quadratic inequalities for sure in this part of the lesson. But the first thing you want to do is write the inequality. So on one side you have one fraction. You want just one fraction, so you need to combine it. And then on the other side of the inequality you have to have 0, okay? And then you're going to, when you look at your fraction, on the side of the inequality that has a fraction, you need to find out what would make the numerator 0 and what would make the denominator 0. So you might have to factor those. It's all right here. And then any number that makes the numerator 0 or the denominator 0, those are going to be like special values, okay? We're going to plot every single one of those points on a number line, and we're going to have to test every region in between all of the points. So let's say our smallest number that we got was -3. That region that goes from -infinity to -3, we would test, and then after -3, the next number was 1. Then we'd have a region, we would pick any number in between -3 and 1 to test, okay? But the thing is, you can have, with the quadratic inequalities, you would only have a maximum of 3 different regions. Here we could have more. And then we're gonna use interval notation to express our solution, okay? All right. Does my hair look okay? All right. So I am going to erase this. You can always rewind it if you need to. And then let's try one. These are pretty neat. Let's try a couple. All right, the first one, let's say, these can be tough. So let's say I have 5 over x plus 4 is greater than or equal to 1. All right. The first thing we're going to need to do is get 0 on one side. Yeah, it's not terrible. So we're going to subtract 1, and I get 5 over x plus 4 minus 1 is greater than or equal to 0. But the problem so far is that we don't have one fraction. We have this fraction and we have this number 1, which is a fraction if you look at it as 1 over 1. That's okay, because we can combine them if we find a common denominator. One thing is, what does this denominator need? This needs an x plus 4. But another way to look at it is, instead of writing it as 1, and rewind this and watch it again if you need to, but instead of rewriting it as 1, let's write it as x plus 4 over x plus 4. Isn't that the same as 1? It is, right? And the advantage of this, now I have a common denominator, and I can just do 5 minus x, and I would get -x, and then 5 minus 4 would be plus 1 in the numerator when I combine my like terms in the numerator. And the denominator, remember, when you're adding fractions and subtracting fractions, the denominator will stay the same. X plus 4 is greater than or equal to 0. Okay, now we're going to use this to find out our special values that we're going to put on a number line. And those special values are any number. Sorry, I had to walk and make sure I was recording, so I went up here. Any number that would make either the numerator 0 or the denominator 0. Okay, so if I want to find out what's going to make this numerator 0, and I said -x plus 1 equals 0, and I added x, I would get x equals 1. That's going to be one of my special values. It's easier for me to see what's going to make the denominator 0. I see that -4 would make the denominator 0. So my other special value is x equals -4, okay? So I'm going to put those points on a number line. My smaller one is -4, so I'll start with -4, -3, -2, -1, 0, 1. My bigger number is 1. So I need to test those numbers we're going to use to define the regions that we need to test. okay? So this region, anything to the left of -4, I need to test. We're gonna see if that is true or false. Then we'll check this middle region, and we'll check this right region. I'm gonna clear a little space here. We're gonna use the most simplified version of an inequality, which I believe is this right here. And what's a good number to use? I mean, you can use anything you want to the left of -4. I think -5 is a good number to use. So I'm gonna replace the x's with -5 and see if it turns out to be greater than or equal to 0, then it would be true. So I would have -5 plus 1 over -5 plus 4, and we're gonna see if that's greater than or equal to 0. Okay, so -5 is 5, right? 5 plus 1 is 6 over -5 plus 4 is -1. And 6 divided by 1 is -6. -6 is not greater than or equal to 0. So this region, every number in this region is going to be false, okay? The solution would not include anything from that region. All right, let's pick another number in the middle region. I can pick any number I want in that middle region. I'm going to choose to use 0. 0 is easy to use. Because if I use 0, I would get -0 plus 1, so it'd be left with just 1 on the top. And on the bottom, I'd have 0 plus 4. And so the zeros don't mean anything, and I have 1/4. Now, is 1/4 greater than or equal to 0? It certainly is. So this region here is going to be true, okay? Now we need to pick any number we want in the third region and see if it's true or false. I think, what do you think? Anything bigger than 1? How about 2? 2 seems like a nice, easy number. 2 is in this region. Let's plug it in and see. So I'll replace the x with 2, so it would have -2 plus 1, because we have a negative, and I replace the x with 2, I get -2 plus 1 over 2 plus 4. -2 plus 1 equals -1 over 6. -1 over 6 is negative. It is not greater than or equal to 0. So this region is false. So my solution for this problem is only true from -4 to 1. But because it has the equal bar, we're going to include -4 and include 1 when we write our integral notation. So the smallest number it is allowed to be is -4, but including 4, so I give it the brackets, right? If it didn't have that equal bar, it would get parentheses, okay? All the way up to 1, including 1, so we'll give that a bracket as well. So this says my solution is true for this inequality at the range of anything from -4 to 1, okay? Let's try one more. All right. 2x minus 1 over 3x plus 4 less than 5. Okay. So the first thing we're going to need to do, move 5 over. So I'm going to subtract 5, and I'm going to subtract 5. That was weird. Let's do it right there, okay? So I have 2x minus 1 over 3x plus 4 minus 5. Now I have to make this one fraction. So I'm going to find a common denominator. This one only has a 1. It's missing a 3x plus 4. So I'm going to multiply by 3x plus 4 over 3x plus 4. And now this is going to be less than 0. So now I'm going to combine the like terms. So I have a 2x, and then I'm going to distribute a -5 to these two. I'm sorry, 2x minus 1. And then I have a -5 that I'm distributing, so that's minus 15x. And then -5 times 4 is minus 20. And if I combine like terms, I get, let's see, 2x minus 15x is -13x minus 21 over my common denominator of 3x plus 4 has to be less than 0. Now we're gonna find anything that would make 0 in the numerator and in the denominator. So I can do that by setting negative 13x minus 21 equal to 0. Oh, add 21, I get negative 13x equals 21. Divide by negative 13. And my first special number is 21 over negative 13. So I'll write that right here. X equals negative 21 over 13. Let's find our other number. That's going to go find our other region. Well, that one's a little easier. 3x plus 4. If I subtract 4 and divide by 3, my other one is going to be x is equal to negative 4/3, right? So those are my special regions. These numbers aren't the friendliest numbers in the world, are they? Negative 21 over 13, negative 4/3. We're going to make a number line. Negative 4/3 is just a little bit smaller than negative 1. So I'm going to say, like, right here is negative, how should I do this? Negative 4/3, right? If this is negative 1. And negative 21/3, oh my gosh, let's make this number line bigger, because these are so close together. So let's say this is 0, and this is negative 1, and this is negative 2. Negative 4/3 is just going to be 1/3 of the way over here, so negative 4/3. We'll call it right there. And then, let's see, negative 21 over 13, that is not quite negative 2, but it's a little smaller, so we'll put it right about there, negative 21 over 13. Okay, so first, those numbers are going to define our regions. I have to test any number to the left of negative 21 over 13, and then a number in between the two of them, and then a number to the right. So first, let's just test negative 2. That's nice and easy. Negative 2, if I put it in here, let me erase this here. Let me erase some of this here. If I put in negative 2, I would have negative 13 times negative 2 minus 21 over 3 times negative 2 plus 4. Let's see. Negative 13 times negative 2 is positive 26. 26 minus 21 is 5. 3 times negative 2 is negative 6. Negative 6 plus 4 is negative 2. So this time we're looking for anything that's less than 0. So since this is negative, this is less than 0, this will be true here. This middle region is not going to be as much fun to check. We need to find a number that's in between negative 4/3 and negative 21/13. How about negative 20/13? I know that's just a little bigger than that. I know it falls within that region. So I'm going to replace every x with negative 20/13. So I have negative 13 times negative 20 over 13, and we're going to subtract 21 on the top. And on the bottom, we're going to have 3 times negative 20/13 minus 21. All right, so luckily, negative 13 times 13, those would cancel. So I'd have negative times negative 20 minus 21, which equals a negative 1. Now here, 3 times negative 20, 3 times negative 20 is negative 60 over 13. So that's going to be negative 60 over 13. And then to find a common denominator here, I'm going to multiply by 13 over 13. And I'm going to get, let's see, negative 60 over 13. I need a calculator for this. 21 times 13 is 273. So I get negative 60 minus 273 over 13. And I get negative 333 over 13. Well, hang on. We could go on further and simplify this if we wanted to, but what's a negative divided by a negative? Is it going to be a positive? And if it's positive, it can't be less than 0, right? So that's got to be false, because whatever we got here is positive. Rewatch this if you need to. But this region is gonna be false here. That region is gonna be false. Now the last one's gonna be easy to check. You wanna know why? Because we're gonna use 0. 0 is always a great number to plug in. If I replace this x with 0, this term goes away, and I'm left with just negative 21. If I replace this x with 0, this term goes away, and I'm left with just 4. Okay? So, is that true? Well, yeah, because it's negative, and anything that's negative is going to be smaller than 0. So this region is true. So now we just need to use interval notation to say it's true here, false here, and true here. So what's the smallest number where it starts being true? Would it be negative infinity? All the way up to negative 21 over 13? And since we don't have an equal bar, it's not going to actually include negative 21 over 13. We're going to parenthesis it, and we need to union it with the other set of values where it starts to be true again. So I'm going to union, then negative 4/3, and then all the way, it'll be true all the way to infinity. What do you think? Pretty neat, huh? Do your best, work on these assignments I put out for you, and then I'll answer some questions when we get back. Thank you guys so much. You guys are awesome.